virtualization. Many applications will be able to query this SQL database, making queries over the table without knowing the information is in a completely different place. So, I can execute this, will not make any problem, but the fact is that this sales database already has this external data source and many others. SQL storage pool is already here. This is not a default. This was created by the step-by-step of the workshop that I said about. The workshop provided by Microsoft create this environment with the sales database with these data sources. But what I need to highlight is that these data sources created here are very, let's say, very basic data sources, extremely basic data sources. And we need to have them probably in every database that we will create inside our environment. Every database will need these data sources. Take a look here. The location of the data source. Controller SVC, the controller service of our cluster. And the full, and the protocol SQL ADFS. So we are accessing the storage pool. Creating a data source on this, with this format are giving access to us to our storage pool. So from SQL, using SQL queries, I'll be able to query the information which is in the ADFS storage pool. That's it. Since there is an if here to check if it exists, I can execute this with no problem. Nothing will really happen. Now, let's create an external table. Create external table, web click string ADFS. The table has this end in the name ADFS to identify the table is inside the storage pool, inside the ADFS environment. We have the structure of the table, the fields as begin, but note the last part. We have the data source, SQL storage pool. The data source says that the table is inside the storage pool. That's it, nothing more. But we have here the path where the table is. The table is inside the folder click string data. So inside the storage pool, the folder click string data will be mapped to this table. But a folder can contain many files. Yes, it's how ADFS works. You can map a folder to a table and all the files will be read and loaded as part of the table. And the file format, which format of the file are we dealing with? We are dealing with a CSV file. This is the name of the file format created before. The object file format sets the format of the file. So let's create this table where we click string ADFS. That's it. Let's make a simple select over this table. Select top 100 from web click screen strings ADFS. That's it. We are reading in SQL information that is contained in a CSV file, inside my ADFS environment. That's it. Just that. Now, let's make something more interesting. I don't need only to read the information. I can process the information, make calculations with this information. I have here this query. With this query, I'm getting my external table, which is inside ADFS. My external table is inside ADFS. Here. And I'm joining this table with a table item and making a grouping by. So I'm joining a table which is in the ADFS, is in a CSV, with a table which is inside my database. I'm making a join of them. So let's make a join of them. That's it. So it's processing. And in some more seconds, I'm joining a CSV to a SQL table. There it is. 88,000 rows. As a result, 88,000 rows, resulting on the join of the CSV table in the ADFS environment and the SQL table. That's it. So in one query, I join it both together. And the applications don't need to know where these tables are. The applications don't need to know. They will only make SQL queries. Just that. Our environment will be a virtual data lake, a data virtualization platform. The information is here. The application thinks the information is here. But our external tables are able to get information from external environments. On this example, I use this external data source, which is called SQL Storage Pool. This means that I made my master, I'm connected to the master, read information directly from the ADFS. The master went directly to the ADFS. But I have other data sources here. I have a data source called Hadoop data. In this case, instead of going directly to ADFS, my SQL master will request the information to the Spark endpoint. And the Spark will make a job to retrieve the data from the ADFS. So, I will create another table. Is absolutely equal the previous table, but this time I changed the name. Of course, I can't create with the same name. I changed the name to the end of Spark, and I changed the data source, Hadoop data. So this time I'm reading information from a different data source. That's it. So let's make this select top 100 from web click strings Spark. Let's execute. That's it. So we have the result. Now it was read through Spark and not through directly from ATFS. How can I understand this? How can I discover this, that this was read through Spark? Well, to identify this kind of thing, we need to monitor system tables. Like for example, we have here the sysdm exec distributed requests. So I can execute this query and it will list for me the last distributed request which happened. The last distributed request executed. Probably according to the total elapsed time. I think this one is the QID 239. Let's check. Then I use the system view sysdm exec DMS workers. What's DMS? DMS is a service that follows Polybase, was created since SQL 2016. It's called Data Movement Service. It's a service responsible to move data among the nodes, the data nodes. So the DMS will show to us the steps executed. I'm filtering these steps because I know what I'm looking for to identify what happened. So I have here external reader, going to the ADFS, and parallel copy reader. Why do we have this parallel copy reader? The point is the environment identifier that the information was read just a few seconds before and used cache. But the important part is that we have two external readers going to the endpoint ADFS. The ADFS endpoint means that they are going to Spark. And here we see our queries distributed, easily distributed. Okay, to make it better, we need to repeat the other query and identify the difference. Let's repeat this other query, which is reading the data now from ADFS, directly from ADFS. Run. Then the data is there. Then let's check the distributed requests. So the elapsed time was very low, probably this 149. Let's confirm that is 149. I will query the sysdm exec DMS workers. And now I have many external readers. I don't have only 2 external readers. I have many external readers. Why I have many external readers? Because each one is completing part of the task to read the SQL ADFS. Mind the protocol SQL ADFS. So it is going directly to the external reader to complete this task. When we were using Spark, we had only 2 external readers, and the problem was a Spark problem. The problem was sent to Spark. But now, reading directly from ADFS, we need to have many external readers to read the ADFS. So we can identify using these system tables if the query was using the data source, was using Spark or reading directly from the ADFS. And there is a difference on this. The difference is the ability to push down. If we are using Spark, we have the ability to push down to a Spark job. If we are not using Spark, we don't have the ability to make the push down. We can't make the push down. And that's a problem. That's a problem. These other samples are exactly the same. I just changed the order of the demonstration a bit. Let's go ahead and create a new file format. This file format is a compressed file format, and that's very interesting. When we talk about file format, we are not only talking about CSV or Parquet. I can have a compressed file format using gzip compression, gzip codec. So let's create this compressed file format we will use in a while. Already exists. I forgot to delete them from my previous text. It's there already. Let's create a schema called est. Already exists. I forgot to delete it. And now I'll create the table trip. Create external table trip. This external table is going to a folder called New York Taxi Trip 2013. And using the compressed CSV, it will read data compressed. But what is this New York Taxi folder? I don't think we have a New York Taxi folder. If you check, we check our ADFS environment. In fact, we don't have a New York Taxi folder, because this New York Taxi is a public blob storage maintained by Microsoft, providing a lot of information that we can use for samples and tests and so on. But it's not here, it's not local, it's a remote blob storage provided by Microsoft, but it's public. There isn't any kind of authentication for this blob storage. So what I need to do, I need to mount this blob storage. So I get the instruction to mount this blob storage, which is az data abdc adfs mount. create remote URI, WASPS, and the address of the blob storage and container. Mount path, New York, taxi. So I'm mounting an external blob storage as a path of my local ATFS storage. This time I remember to not close this window. Okay, I'll paste this instruction here. And that's it. The mount request was submitted to mount the external blob storage in our local ATFS. Let's make a refresh. Mine the folder NI taxi. At this moment that I immediately made the mount, is not showing the symbol that this is a mounted folder, but if I close and get back, the symbol will appear. It's a bug on the visual interface. And I'm seeing the content of this folder. There are a lot of data here. Each folder is a table, is intended to be a table. And the trip 2013, mine that is txt gz, is a compressed CSV. So I already created the format, and I will use my local data source. I will use the Hadoop data and execute. So I just created this external table, and let's make a select. And I'll make a select of 100 records. That's it. I just read 100 records from a blob storage that is somewhere on Microsoft environment. I have no idea where it is. It's not on my environment. And I retrieve the data as it were local to my SQL Server. That's the point. And that's what we're talking about, data virtualization. We get external data and map as if the data were local data. There are some queries here to make, some calculation, but I'm using the Hadoop data source, and this content is compressed, so this query takes many minutes to execute. I will let for last. I'll leave for last. Let's make another example. I'll create a Parquet format this time. Already exists, I forgot to delete. This time, I will read information from my environment. I have an environment, you can notice here, in Azure Blob Storage. I have an environment, one storage account called Data Lake Demo Malta, one sample container, and I have a folder Geography. Inside this folder called Geography, I have a Parquet file. I have here a Parquet, just that. And I need to map this data source to my environment, and I can mount this data source. And mind that, I'm showing examples mounting the external blobs to my ADFS environment. That's one way to do that. But another way to do that would be to create external tables directly to the external blob storage. This is also possible. We have many ways to access the information. But I will make a mount. In this case, I'll make a mount. But this mount is more complex. Why this mount is more complex? Because this is a private container. The access to this container is not public. Since I'm doing the mount on the command line, I need to set an environment variable, mount credentials, with some information about my container and the key to access my container. So I'll set this environment information. This is only important in the moment I'm doing the mount. After I do the mount, this is stored, this is saved with SQL BDC, and this will not be needed anymore. But in this moment, I set the credentials and I'll make the mount. I'm using a different protocol, ABFS, because the ABFS is the protocol used for the DFS endpoint. When we use blob endpoint, we use the WASBS. But when we use DFS endpoint, we use ABFS. That is it. Created. Let's make a refresh. And now I'm not only seeing my new mount here, but I'm also already seeing the symbol showing that these two folders are external, are not from my local ADFS. They are mounted from external locations. And I can access the folder demo Malta and check the content of the folder geography. There is a Parquet file inside the folder geography. So I created the geography table. It's complaining the table already exists. Let me drop external table as geography. Okay, now I will create the table. Create table as geography and select top 100 from geography, and I'm already reading information from my blob storage, my private container, which requires authentication, and SQL BDC is authenticating to my private container, because I gave the key when making the mount. I gave the key to SQL BDC when I made the mount. So I'm already having access to it. Okay, done. So we already saw how the storage pool works. The true access to the storage pools. So let's get back to our PowerPoint. Essential data sources that we just saw is the SQL storage pool. This one we saw the code to create it, and the Hadoop data to access to the ADFS through Spark. This data source, external data source, needs the type specified as Hadoop and resource manager location specified as the Spark head location. It's the resource manager of Spark. Now let's talk about data pool. We talked a lot about the storage pool, but we haven't talked too much about the data pool. What's the data pool? Well, we saw this architecture, and we already saw in detail some examples of this architecture using the storage pool. But why do we need the data pool? I have the master, which is a SQL Server. I can have database in the master. I can have local tables in the master. Why do I need a data pool? Simple. When I create external tables to access these external resources here, and in ADFS, and inside ADFS tiling, and we create external tables for these, the access will not be fast. It will be a bit slow, acceptable for the purpose of the access, but it will be slow. How can we solve this? We can bring data marts for our environment. We can bring small portions of data to our environment and process this data in our environment. That's what the data pool is. The data pool is a local cluster of data to process big amounts of data, which will be our data mart, a local storage that will make the access to immediate information faster. We can use this for data analytics. We can use this for Power BI reports instead of using a slow source because we need to get data externally. We create aggregations, we create specific views of the data and include these views inside our data pool, which will become our data mart. Then we have another essential data source, which is a data source for our data pool, a SQL data pool data source, using the protocol SQL data pool, pointed to controller SVC. Let's see how it works. Let me open another query file, data pool demonstration. First, we have here the creation of the data source, which I don't really need because the data source already exists there. I need here to select the database, connection database. Let's connect to an existing connection. And then select the database, sales. But we know this data source is already there, as I have shown before. That's it. SQL data pool is another data source preview. Is there because this is a simple database built by the workshop, but it will not be there in your database. You will need to create these data sources. So you need to remember these basic and needed data sources for BDC. So executed. First, I would like to illustrate very well the difference between the master node, which I'm seeing here. I'm seeing the master node, and the two data pool nodes. Let's see how I will illustrate this difference. Let me create a database. Use master, create database, testing. So, very simple. Use master, create database, testing. That's it. So I will select this and execute. I have a new database. Testing. Where is this database? Is in the master node. What happens with the two data pools? They have no clue about this database. How can I know that? Take a look on this execute. Use master, select the star from this database. But the most interesting part is add data source SQL data pool. This means that I'm asking to execute this statement on the data source SQL data pool, not here, there. I'm forcing a push down in some way. I'm forcing the execution of this instruction in the SQL data pool. But the SQL data pool means two SQL servers, not one, and could mean many others. In this environment means two. I could have 10 in the data pool. Could be many others. So I will execute this query. Oh, I'm with the master selected. I need to go back to sales because my data source is on sales. So I will execute this. And here I have my list of the database returned by the SQL pool. But I don't have one list of the database. I have two lists of the database because I have two SQL pools. Sorry, two nodes in the SQL pool. So I have two lists of the SQL database. But testing is not here. The data pool doesn't know the database testing. If I really would like to create the database testing inside the data pool, I will need to execute the instruction add data source SQL data pool. Let's see this example. So I will execute the instruction inside the SQL data pool. Let's query this database again in the SQL data pool. That's it. So I'm querying the SQL database again, and now I have testing. That's it. Now I have testing. So I created the testing on the two nodes of the SQL data pool. This is an interesting example to illustrate that we don't have one SQL server. We have at least 3 SQL servers if you consider only the data pools. But the compute pools also have SQL servers. So here, now I will create another table, which is a table which will be created inside the data pool. Creating external table, name of the table, and this table will be created inside the data pool. And mind that we specify also the distribution of the table. What this means? This means how the records will be distributed among the pools. In this case, I'm choosing round robin. So I'm choosing to distribute the records in a round robin way among the pools. So, done, the distribution is made by round robin. I can see the table here, but I can see the table as an external table. Let me make a refresh to be sure we'll see this table. I can see this table, data pool, as an external table. It's not a local table on my master node. It's an external table. Now I insert records inside this table. So let's check this. So I'm reading data from the ADFS table that we created before, making a join with the item table, and I'm bringing the result of this join to our SQL data pool. It's not just a table. I'm relationing making a relation with the data. I'm making a group by. I'm creating a specific view that I need, a specific visualization that I need, and this table in my data pool will be like a data mart. I can use for a fast visualization of the result. It's executing, taking some more seconds to execute. Total execution time, 27 seconds. Now I can check the count of rows on this table. It has 1,932 rows. And I can make a simple query, select top 10. And over this table in my data pool, I can make further analysis, further joins, like this other query that I'm executing. And now I'm executing over the SQL data pool without the need to go externally to the external tables. So I'm making an analysis inside my SQL data pool. Let's see another vision of how this table is distributed in the pool. I will use the execute again, use sales, select count star from this table. Add data source, SQL data pool. So I'll get the count of records of the table on each node of the pool. And the result is that one of the nodes has 1,250 records and the other node has 682 records. So if we sum both values, 1250 plus 682, we have 1932, which is the count of the table. So the records of this table are broke in two different instances of SQL Server. When we make the query is broke in two instances, and the result is measured when come back to us. So let's get back to our PowerPoint. Let's see a summary of what we saw on this presentation. We saw Big Data Cluster has a data lakehouse tool, a storage pool using ATFS tiering, directed storage pool queries and Spark queries, external tables plus ADFS tiering as a data virtualization technique. Data virtualization results in a virtual data lake, and data pool as a local cluster for data mart. And here is the link for the workshop. As I mentioned, this workshop starts from the basic and has the step by step for you to understand the architecture and install the SQL Big Data Cluster, and then understand better what I just explained, since I didn't went deeper on the architecture. Thank you very much for attending this session. Here are my contacts. Feel free to get in touch, send an email, access my site, follow me on Twitter, LinkedIn. Feel free to keep in touch. Thank you very much for attending this session.